Hi class. So this section is 6.2 and we're going to be discussing ionic compounds. What happens when those positively charged ions and negatively charged ions come together, creating an ionic bond, which is now an ionic compound. So ionic compounds consist of positive and negatively charged ions that are held together by a very strong attraction between the oppositely charged ions. Sodium chloride is a perfect example. We write it out like this, which we'll be learning, but this is actually what it is. It's got a plus charge and a negative charge, and there's a very strong attraction between these opposite charges that hold them together. How strong? Significantly strong. The bond between them is not an actual bond, it's more of an electrical attraction, but we call it an ionic bond. It consists of positivity and negative ions. So the positive is metal, negative is non-metal. It has an attraction called ionic bond. So again, we call it an ionic bond, but it's an electro attraction between the oppositely charged ions. Have very high melting points, these ionic compounds, and they are solids at room temperature. We know sodium chloride because it's salt. However, high melting point for salt. So it will have to reach 801 degrees Celsius or 1474 degrees Fahrenheit before it'll start melting. Sodium chloride will not boil till it reaches 2,669 degrees Fahrenheit, and we'd all pretty much be dead. So we don't have to worry about something like that. But it takes a lot of energy in order to ionic compounds to break down. Here's a picture of salt, and then it's it goes in closer on a actual crystal. And what you don't see on the molecular level is the chloride is the green, the sodium is the purple, because remember they lose, so they become smaller when they're an ion, and chloride becomes larger. And there's a pattern. It's a certain arrangement. It's an arrangement of, they're all encompassed by each other. So if you take the green one, it has several sodium ions around it, and the chloride, and then the chloride will surround all of the sodium. So it's vice versa, and they're all completely covering each other in a specific pattern that allows them all to be attracted to each other with all these. That's what makes it so strong, is that when we talk about one, there's not one in here. There's millions and millions of this going on in here, but we talk about it as it's one. But what you see is there's chloride, sodium, chloride, sodium, and all these attractions hold this together. Very, very strong. Sodium chloride is an ionic compound. We've already discussed this. If you look at the beginning material, so sodium metal is a solid, and it's a very dangerous solid to work with. I've worked with it. It cannot be into any contact with water. It is very, very dangerous. I used to have to prepare to work with this because it's so dangerous. Has to have everything around me in case anything went wrong. Chlorine gas, also very dangerous. It can kill you. It's been used in wars. So this is also, both of these materials are very, very dangerous in their existing natural state. However, when they come into contact, they become sodium chloride, which we use our food, we use to boil water. It's not as dangerous unless you're using it at toxic levels. Chemical formulas of ionic compounds. So we have learned the elements. So if we look at the Na, we know that that's sodium by now. You should look at a periodic table and know that. Same as Cl. But how do you write them when it's a compound joined together? That's what we're going to learn. In a chemical formula, the symbols and subscripts are written in the lowest whole number ratio of atoms or ions. What does that mean? That means that we do not use fractions. We do not ever use fractions. When we write this out, there will be whole numbers. So we will put subscripts. So you have to understand, when these are above, they are superscript. When they are below, they are subscript. So if there are numbers here, that's going to tell you how many of those exist in that compound. And overall, when you do the math for it, it should equal 0. So when we write sodium chloride out, what you don't see, and these are, again, these little things that you're expected to know in chemistry. It's like a secret club with all these weird little things that you just have to know, even though they're not written out, they're not spelled out, you have to learn them. Well, we write NaCl. What you're really saying is that They are electrostatically attracted to each other. They are both ions. One is a positive, one is a negative, and you also have to know how many was lost on these. Sodium has a group 1, so it will lose 1. It is a positive charge. Chlorine has 7 valence electrons. It can take 1, so it takes an electron. It is a negative charge of 1. And when you multiply them, so we have 1 sodium with a +1 charge, and then we add that to 1 with a -1 charge, this equals 0. So NaCl, there's actually, what we don't write out is a 1 here and a 1 here, and that tells us 1 and 1. Sodium lost an electron and gave it to chlorine. That electrostatic attraction is the ionic bond, and it keeps them together very, very strongly. Subscripts. Okay, so here we go. Now, what if we're dealing with one that gives more than 1 valence electron away, which we will. Here is kind of a drawing. So we have a magnesium with the Lewis dot structure here, and it loses 1, and it will give it to 1 chlorine, which now becomes chloride, and it will give that other one away to another chloride. So the attraction now is within 2 chlorines. So you see the size, this got smaller, these got bigger. And it'll stay attracted to that, very similar to the arrangement that you see here. That's how they're patterned out. There's a very distinct pattern that allows them to stay that way, and that keeps that strong, strong bond of all these attractions to each other. How do you write this out? Well, we know that we have magnesium with a 2+, but we also need 2 chlorines, and it's a -1. So if we wanted to balance this out to make sure, we would have to take 1 chlorine, which we have 1, but it's a 2+ charge, and we add 2 chlorines with a -1 charge, and that equals 0. So we know that because this is 0, we need 1 magnesium and 2 chlorine. How do we write that out? Well, you would write it out like this. Magnesium, and you need 2, so there's a 2 here. You would write it as a subscript, and you would simply write out the name, magnesium chloride. There is no indication when you're dealing with ionic bonds how many consist in here. Again, here is one of those fun things that makes chemistry very difficult. If I tell you magnesium chloride, you will have to learn how to write the chemical formula out and what numbers go with it. How do you do this? Practice. That's all it is. It's practice. But one thing your book does not do, and I don't like this, a lot of books don't do this, they don't show you an easier way to do this. So this is not in your book. I'm going to show you how to do this. It's very simple. It's easy. It will help you. Instead of doing the math that they want you to do, they want you to do this math constantly with every chemical formula. You don't have to do it with the way that I do it. You can do it to check, but you don't have to do it. So we have magnesium. I give you magnesium oxide. Oxide, this is an ion. Remember, we lose the YGEN from the oxygen. It is now an ide. You have to put that. Magnesium stays the same. Now, magnesium oxide. This is a cation. This is an anion. We're going to break it down. I want the chemical formula for this. So you write magnesium and do this in steps. While you're learning this, take the time to do this. This will help you. Next, write the chemical formula as an ion. So Mg, I hate that this is very light, but Mg 2+. It's a group 2, so it's a 2+. Oxygen has its group number 6. It needs 2 more, so it has 2 minus. Okay, so what you see here is that this 2+ went over here. So this was lost, this was taken. There's just no arrow to show that. Now, this is called the crisscross method. Crisscross them, that's it. See this purple line? You put it here. I put a 2 as a subscript. See this blue, very blue line, which I don't know who would do this. Put it here and bring it together. So I have a 2 and a 2. Now, this means that I need 2 magnesiums for every 2 oxygens to make this magnesium oxide. But this is actually not correct because we need to reduce these down. So what this meant here, when we're talking about lowest whole number ratio, is that when we deal with ionic compounds, we deal with the lowest ratio. So you have to reduce this down. Everything that can be reduced down has to account for this side and this side. If this had a 1 here, you can't reduce it down because it's going to leave this as a fraction. But this is a 2 and a 2. You have to reduce it down, and we do. So MgO. This actually means this And this is where it gets hard again. You're going to have to know that. If I give this to you, or you solve for this, this is the final answer. This is wrong, because the rule is it has to be reduced down. If you get confused with this, there's the book method that teaches you to do the math for it. There's a 2 plus, and you have one of them. Is that right? 2 plus 1? No, there's a 2. Yeah, there's 2 plus with 1. That's what this is 1 here. And then I have a 2 minus with 1 oxygen. So it's 1 and 1, but one has a 2 plus charge and one has a negative. So what this means is that the charges cross over and it reduces down. Now, you have to give it like this. Not all of them are difficult. We write sodium chloride out and it's just a 1 and 1. So you don't even think about it. There is no crisscross. It's just 1 and 1. But when you have either the metal or the non-metal that has more than a 1 charge, you have to account for it. So here are some others. I found these online. That's why some of them don't look that great, because the book doesn't give this to you. Crisscross method. So if I give you lithium oxide, which is this, lithium is group 1. So this one shows a 1. It should write like this, but for learning, I can see why they do this. So a 1 number in first, then charge. And then you bring it down to the oxygen, and the 2 minus goes down to the lithium. Now this accounts, and if you do the math for it, very similar to this, or the math to this, it balances out. You don't even have to do the math. It balances out. And here's another one. Crisscross it down. So this is 2. This is 1. Use a 1 if it helps you right now, but you have to remove the 1. You can't keep using it. So this is lithium oxide. When you say the name, it doesn't account for the number. These are these weird things about chemistry. You're just going to have to know that that's what it is. Here's sodium, and here's sulfur, which is now sulfide. So crisscross them down, the 2 comes down, the 1 comes down, Na2S. Nothing to reduce down on these because you don't want fractions. So here is a problem. If I give this to you, write an ionic formula of the compound. So you've got to bring these together, and at the end, the charges should not be showing. So bring these down. I'm just going to show you the page of how to do this. But bring it down. Now you could do it the book way, which is this way, or you can do the crisscross way, which still matches. Bring down the 2 plus to the chlorine, which is now chloride, and bring the negative, which would be right here. This is the compound, barium chloride. There's no mention of the 2 or how many. The name is just barium chloride. Cation is always written first, anion is always written second, and then you crisscross, bring them down. Nothing to reduce. If you do the math, you will see that this actually balances out. All right, so let's do some practice on these. Here is the first one. The answers are all shown on one page, so we're going to work these out first before you look at the page. So sodium has a +1, so we don't look at it. Here's the key. If it's a plus and a minus, then it's a 1-to-1. You don't worry about it. Just write it. But if you look at these and you see that one has more than 1, that's the one you want to work with. So we're not going to pay attention to sodium. We're going to work on this one, the 2. Excuse me. Knowing these crisscross, that means that this 2 has to end up on the sodium. So if we look at this here, there would be a 2 here. It has to end up on the sodium. So go down these and see which one ends up on the sodium, and it's B. That's the key to look at these to understand how to write them. Look at the 1, and now as we progress further, you're not even going to have this. You're going to have to just know what charges are on these. But for now, this is how we're starting out. Here, this has a 3. This has a -1. So we're not looking at chlorine. We're going to look at aluminum. This is going to crisscross down to over here. So the 3 should be on the anion, the metal, the non-metal. So if we look across, the 3 here is just brought down. This one doesn't have anything, and it's the first one. The 3 gets crossed down if you can visually try to see that. So it's A. And now this one's a little harder because we have magnesium that has a 2+, and we have nitride with a 3-. So it doesn't matter on these. Pick whichever one. So I'm going to pick 3. And if the 3 is on nitrogen, it has to go on the oppositely charged ion. So it means that the 3's got to be here on magnesium. So I'm going to look, and it's going to be this one. Now, to confirm, because this one's a little more difficult, look at the magnesium. The magnesium needs to go on the nitrogen. So look for the 3-2 sequence. And here it is. Magnesium, The nitrogen takes the 3 over to magnesium, and magnesium has a 2 plus and it crosses over. So if we're right, we can see. So write these out and do the crisscross until you can start visually seeing this. And believe it or not, you will. You will get to a point that you won't have to write these out. You'll just visually see what's happening. These are these weird little things about chemistry you're expected to know, you're expected to retain, and it forever to never go away. As we do more of this, it will get easier. Okay, and that's it for 6.2.